We're told in this problem to calculate the binomial coefficient 10 choose 5. And you can see over here on the right side, I've given you some ways to interpret what this weird symbol means, this n over k. It's not a fraction. It means n choose k. Or in other words, there's n people in a room. How many ways are there to choose k of those people? This is called a combination. So it would be helpful if we had a formula for this. I'm going to write that down here. The formula for n choose k is given by factorials. It's going to be n factorial on top, k factorial on bottom, and then an n minus k. Okay, that's n subtract k factorial. So let's see how that works for our example. We've got 10 choose 5. So what that's going to be is 10 factorial on top, 5 factorial on bottom, and 10 minus 5 factorial, which is actually going to turn out to be another 5. It's an interesting coincidence that it won't always happen that way. So we've got 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. Okay, that's how you write out the top of this thing. And on the bottom, I've got a 5 factorial. That's 5 times 4, 3, 2, 1. But I also have another 5 factorial, this guy right here. Okay, that's going to be 5 times 4 times 3 times 2 times 1. Now, it won't always happen that they're the same, but we'll just keep going for this problem. You see how it's kind of tempting to just say, boy, that's going to be a lot of big numbers. Why don't I just plug this into a calculator and be done with it? I would recommend not doing that because you're more likely to make a mistake the more numbers you have to plug in. Instead, let's do it this way. I'm going to cross out every pair of things that I see which makes for a nice factor. For example, there's all the 5, 4, 3, 2, 1s. Those are crossed out. And now there's other factors in here, right? Look at this. I've got a 4 and a 2, and those make an 8, so I can cross those out. And if I want to get fancy, I could say, okay, my 5 crosses out with my 10 and leaves a 2 behind on top. And my 3 crosses out with my 9 and leaves a 3 behind on top. So what's left? Well, let's count them all up. There's a 2 times a 3 on top, and there's a 7, and there's a 6. That's all that's left. On the bottom, it's just a 1. So now, by all means, plug this into a calculator. 2 times 3 times 7 times 6. And what you get is 252. Kind of a big number. But you see, we don't have to deal with anything like the millions we would have gotten if I had multiplied all those other things together. So this is called your binomial coefficient, or 10 choose 5. In other words, if there are 10 people in a room, there are 252 combinations that you could choose 5 of those people in.